So let's go ahead and take a look at that same problem, only this time we're going to be solving it using synthetic division. So we've got the polynomial x cubed minus 4x squared minus 5, and we're trying to divide it by x minus 3. So let's go ahead and talk about setting up this problem. We want to go ahead and write the polynomial in descending order, again with our largest exponent term listed first all the way on down. And this time, instead of using the entire term, we're only going to be using the coefficients. So we need the number and the sign in front of each of those variables. And we also want to make sure we account for any missing terms, right? You'll notice that we didn't have any x terms in this example, so we want to make sure we put the 0 in as the placeholder for that term. Let's go ahead and set this one up, at least with the coefficients. In front of my x cubed term, I've got a 1. In front of the x squared, I've got a negative 4. I don't have any x terms, so I'm going to go ahead and put in my 0 as my placeholder. And then I have the constant, which is a negative 5. And we're going to go ahead and set this up. And the number that we need out in front is our 0. And you remember that that's the same thing as an x-intercept. And it's coming from this factor of x minus 3, which is the piece that we're dividing by. And in order to get the x-intercept, or the 0, we're going to be taking that, the x minus 3, and we'll set it equal to 0, and we'll go ahead and solve it for x. Right? If I add 3 to both sides, and I'm going to end up with an x value here of positive 3. Right? And that's the number I want to use out in front with my synthetic division. Now, we have some hints down in that lower right-hand corner on how to go about starting synthetic division, and the first thing you want to do is bring down that first coefficient. So give yourself an extra line or an extra row right here underneath your synthetic division problem, and we're going to go ahead and bring that 1 all the way down below this line. For the next step, we're going to go ahead and multiply. So we're taking our 0 of 3, we're going to multiply it by this 1, and we're going to put our answer right here on row 2, right there. All right, so 3 times 1 is going to give us 3. And then our next step is going to be to go ahead and add. You're going to add straight up and down. Take the signs just like you see them. Right? I've got a negative 4 plus 3, which is going to give me a negative 1. And then I'm going to go ahead and repeat the process, only I'm not going to need to bring down any more coefficients. Right? That's the only time we actually have to do that step. So I'm going to come right back here to step 1, which is the multiplication step. And we're going to multiply 3 right, times the negative 1. I'm going to go ahead and put my answer up here on that row 2. So that will give me 3 times negative 1 is a negative 3. I can add straight up and down. That will give me negative 3. I need to repeat the process one more time. My multiplication step here, I've got 3 right, times negative 3. It's going to give me a negative 9. And I can add straight up and down. I'm going to get negative 14. Alright, now let's talk about our components here. I'm actually going to start with that negative 14. I'm going to box this in. The negative 14 here is our remainder. And our answer, or our quotient, actually comes from these terms, these coefficients that you have out here to the left of that remainder, right? And we're actually going to start with this negative 3. This is actually your constant term, right? Which is going to stay that negative 3. Negative 1 here is the coefficient in front of your x term. So we're going to have a negative 1x. And then this positive 1 here is actually in front of your x squared term. So you'll have a positive 1 x squared. Okay, and this is the polynomial that becomes your quotient. So we've got x squared minus x minus 3, and our remainder was the negative 14. If you go back and take a look at this same problem that we did with long division, you'll see that you should have the same answer for both pieces, right? Both of those problems had a remainder of negative 14, and both of them had a quotient of x squared minus x minus 3.